I'm going to talk to you today about infinite regress arguments. It's a very common style of argument in philosophy. We're going to encounter it again and again, and it's really helpful to understand the general form. Now, it's not that easy to understand in a certain sense, simply because most philosophers tend to take a lot for granted. They don't really spell out the various steps very clearly in a way that lets you see the structure of what's going on. So what I've tried to do is isolate a common framework that all of these arguments use. Once we've identified it, it not only allows us to understand the arguments, but also it allows us to understand how to avoid them, because we're going to identify three premises. The conclusion follows from those premises. It follows validly. There's no problem with the general form of the argument, which means that if you want to avoid the conclusion, you know where you have to look. You have three possible premises you can reject. So let's take a look at the structure of the argument. There are two basic elements of infinite regress arguments. The first is a class of objects, some kind of collection that we're going to be talking about. So let's draw this collection. This might be a collection of free actions. It might be the natural world itself. It might be a collection of objects. It might be all sorts of things. Really, it's a question of what we're interested in examining. This might be rational beliefs. It might be knowledge. It might be all sorts of things. But that's one element. We need a class of objects that we're talking about. And so the idea here is going to be to say that if certain things are satisfied, then there have to be things outside that realm of objects. We need a name for that, so let's call that D for the domain. The second element of these arguments is some kind of relation, a relation between the various objects in the domain. We're going to think of that most of the time as a binary relation, a relation between two objects, but some of these arguments use more complicated relations, and so it won't always have quite that simplicity, but it often does. So we need a relation, let's call that R. And now we can consider what sorts of things we have to assume about the domain and about that relation in order to make such an argument work. The first thing we have to assume is that there are some things in this domain. So let's say premise 1. I'll call it the non-emptiness premise. Okay? There are D's. There are objects in that domain. We have to have something there. Now, of course, if you get the argument fully going and you want to reject the conclusion, this tells us something important. One of the things you can do is reject that first premise and argue that, in fact, the set is empty. In fact, that's just what a skeptic does if we take the class as being rational belief or argument. To say, in the end, it's going to be a way of showing that there is no such thing as knowledge, that there are no rational beliefs. So we've got to start by assuming that there's something in the set. The second assumption is now one that involves the objects in that set and the relation. The idea is going to be that everything in that domain stands in that relation to something. So we could call this the seriality premise. And the idea is simply this. Every object, like this one that we start out with, stands in the relation to something else. And of course, that thing might well then stand in the relation to something else, and so on. Okay, so the idea is that for every object, it is, as it were, the second term in this relation, if it's a two-place relation. There's always something that stands in the relation to it. So, for any object in D, there is something that stands in that relation to it. So now we've got something in this domain, and then anything in the domain stands in the relation to some object. Well, the key idea, and really the heart of this, the thing that makes it be called an infinite regress argument, is that once we start this, you can imagine it going on to infinity, right? We've got this object, but it stands in relation to this, and that stands this, and then there's something else, and so on and so forth. How do we stop? And so the thought is, look, for a lot of relations, now some relations really are infinite, and it goes on forever. There's nothing intrinsically contradictory or impossible about a relationship that goes on infinitely like that. But some particular relations and some particular domains are going to be ones where we say, look, all of these things can't be true at once. And so in this case, we're going to assume about this relation that it doesn't go back infinitely in this sort of way. Maybe it goes forward infinitely, but it can't go back infinitely. And notice the way I've drawn this. It's a question of going back to something earlier in terms of the relation. So the third premise, we might think of this as the finiteness premise. And it just says this can't go back to infinity. Or to put it in somewhat more sophisticated terms, we can say there are no infinite descending R chains. That is to say, you don't have infinitely many things going back in the relation. So here's an example. Suppose we think of this as something like events in the natural world. And then we can say, well, every event is standing in a causal relation to something else. It's the result of something. So every event has some cause, but then it has a cause of it, and so on and so forth. So we go to causes, causes of causes, causes of causes of causes, and so on. Now, could that go back infinitely far? You might think, I don't understand what it would be to have an infinite chain of causation going into the past. So, maybe not. It's often hard to say, by the way, maybe so, but the point is, we might think at least that that's the kind of relationship that can't go back infinitely. Another nice example of an infinite regress argument is told by Bertrand Russell in his History of Philosophy, where he talks about a story about an old woman who stands up after listening to a philosophical lecture about the origins of the universe. And she said, look, none of this makes any sense. I can tell you what's really going on. The entire universe is supported on the back of an elephant. And the philosopher was given the talk about the origins of the universe, kind of smiles and says, well, that's fine, but what is this elephant standing on? And she says, oh, that's easy, young man, on the back of a turtle. And he said, really? And what is the turtle standing on? And she says, you can't get me with that. She says, it's turtles all the way down. Now, there's something ridiculous about that, right? Here we've got a domain of objects, and then we've got a relation of being supported by or resting on, and the idea is the elephant is on the turtle. Well, the world is on the elephant is on the turtle, and then it's turtles all the way down. It goes on infinitely, just this infinite column of turtles. And you might think, well, that's crazy. That doesn't make any sense. So the thought is here that there can't be, for this particular relation R, an infinite descending chain like that. Now maybe you can just keep stacking turtles on top of each other, but it doesn't seem like they can be supported in the end by just turtles all the way down. Going in that direction, at least, it doesn't make any sense. So the thought is really combined. I'm giving you that nice example, but actually there are three elements to this. And so we might separate those three elements. The first one, since I've said there are no infinite descending chains of this relation R, is really that it implies that there are, well, we could say, no strict chains of this sort. Where what I mean is that each object is different. It's a bunch of different turtles all the way down, for example, or a bunch of different causes going all the way back. Those would be cases where there's never a repeat in this sequence. it's all different things all the way through. Each one is different from everything else in the sequence. But we're able to generalize this idea and say, well, it's not just that there are no strict chains like this. Also, nothing actually stands in the relation R to itself. So we could say nothing stands in R to itself, or just there are no self-Rs. Okay, no cases where something is like this and stands in the relation to itself. That band. So we've got this band, oops, and we've got now this band. Why? Well, suppose something were like this. Then we would have an infinite descending R chain from this object to itself, to itself, to itself again. We can just go around that little loop infinitely many times. And of course, it doesn't matter that it's really just one object there. This is going to generally ban loops. So we can say there are no R loops. We never get a group of objects like this, which are such that we get the relation going around in a circle. So all of those get banned in this one sweeping band, the finiteness principle. Because if we had something like this, we'd have an infinite descending chain. We could just go around and around the circle. Well, conclusion then is what? What follows from the fact that there is something in this set, that anything in this set has something preceding it in the relation, and then there can't be an infinite chain of these. You can't just keep going around in all of this. You might say, well, what if you just stop, like here? Well, the problem is this has to go somewhere. It can't go to itself. It can't go back to either of these. So it's got to go to something else. But it's in the same position. It has to go somewhere else. It can't go to itself because we can have no self-Rs. It can't loop back. There are no loops. And so it's got to go to something else. But wait a minute. Now it looks like we're getting into this situation of one of those strict R chains, one of those turtles all the way down situations. And so what do? Well, here is what follows. If this is going to stand in this relation to something, and by the way, I reversed the direction of the arrows here. Let me fix that. It's got to go to something outside this set, right? It can't be inside this, or we just keep getting forced to go on to something different. It's got to be the case that at some point, this goes to something outside the set. Now, I've said for any object in this domain, there is something that stands in the relation. We aren't forcing this to stand in the relation. Now, it might have something else beyond it, but it might not. And we know this is going to terminate after a finite time somewhere. So somewhere outside this set we start with, we get some object. So what we could say is conclusion. There is a, we could say first R outside our class D. Okay? What I mean more technically is an R minimal element. Something that does not have anything else that stands in that relation to it, with it as its second term. So there's nothing that stands in that relation here. It's the starting point of this chain. And so there's got to be such a thing as that. Now this follows directly, and you can see why. We have something in the set. It has to have a source, as it were, by this relation. It has to have something preceding it. It has to have something preceding it, and so on and so forth. Eventually, as long as we stay in the set, we keep going on infinitely. We've got to terminate, get out of this set. And so there's got to be something out there. Now initially you might think, well, that's not really all that exciting a conclusion. Big deal. Why do philosophers make a great deal out of this? And they do. Plato, as we'll see, Aristotle, Aquinas. base a huge amount in their philosophy on these very principles, but I think you can find a similar argument going on in Descartes, in Kant, in Heidegger, in all sorts of people. And so it's going to be very important throughout the history of philosophy to understand this form of argument. And indeed, when you look at various philosophical positions, you realize that this is often the chart that explains those various philosophical positions. You can accept the conclusion, and that's one kind of philosophical position, but you could also reject it by, for example, rejecting that first premise, saying actually that domain is empty. There are no free actions, or there really is no knowledge, etc. You could reject this and say, in the end, there are things that are just, as it were, free-floating, that don't require anything that stands in that relation to them. You could think there are actual infinite chains, and you could do that in various ways. You could think it really is, at certain points, turtles all the way down. You could think there are some things that stand in that relation to themselves, are self-justifying or self-evident, for example, in epistemology, or are the kind of action that is a free action that in some way is its own source. And so there are ways of defending that kind of position. And then, of course, you might think there are loops or webs where things, let's say, justify one another or stand in a variety of complex causal relations to one another, and it doesn't follow in anything like this chain-like format. Now, one last caution. We've said there has to be something like this, a first element outside that domain, and that does follow. But we haven't shown that there's only one of them. There might be all sorts of these. For example, I've said that at least something, at least one thing stands in this relation to each object in the domain, but it might be that more than one does. So actually it's quite possible that this goes off in all sorts of directions to many things outside that domain. Sometimes people are going to construct arguments where they really want a unique object here. But in other cases, they're fine with many things being outside of that domain. And so we're going to see lots of examples of that as well. But it is important to remember, though I'm talking about there being things in the domain, and then there's something that stands before in this relation to each of those things. In the end, we get something outside, but it might be many things. I mean, we could have this type of situation, for example, and maybe there's something like this going outside to another first object. So we shouldn't make the mistake of thinking in each case there's only exactly one of these. None of this has to line up in terms of one line, like one column of turtles. Maybe it's actually a bunch of turtles stacked on top of one another all the way down.